All right, let's talk about graphs. So for today, we're going to talk about building graphs and graphical parameters. Our objectives are just to learn how to build graphs and to get a feel for some of the parameters for graphs. Okay, so a few notes. You can build a graph one line of code at a time. So you can add to the graph for each line of code. And then a graph can be saved with commands, or you can just use the file menu. So here's the basic plot, or here's the pseudocode. I'm going to run plot of my data. That will generate the original plot. And then I can add title, for example, other parameters. Parameter 1 equals value, parameter 2 equals value, and so on. All right, so I'm going to load the workspace from day 4 because it has some nice data sets in it. The one that I'm most interested in is the class data, which, recall, has all of these variables in it: gender, class, high school, class size, text sent, text received, Facebook time, Pinterest, Snapchat, introversion level, etc. Okay, and again, the first thing that you want to do is read the help file. So here, you'll see plot is a generic function for plotting of our object. So how it works depends on the object and what class it belongs to. For more details about the graphical parameters, see the par function. We'll look at that in a little bit. But here's the basic usage. Plot x, the coordinates of the points in the plot. Y, the y coordinates in the plot. This is optional. So x can be, you can just input x. And then you see you have all of these options: main, sub, x label. You can read more about these by clicking on title, plot window, etc. Okay, so read that one carefully on your own. And to make things easier, I'm going to attach class data. I had already attached it earlier. All right, so now it should not be attached. Okay, so now let's attach class data so we know that we only have it attached once. And run plot. X value is introversion level, so you'll see the plot got pulled up over here. At introversion level on the x-axis, text sent on the y-axis. So for example, somebody had an introversion level of 2 and sent only a handful of text. Another person had an introversion level of 3 and sent 200 texts, and so on. So that's the basic idea with the plot. Here's a trick. If I wanted to fit a line to this data, you don't need to know too much about this, but LM stands for linear model. I'm going to fit a linear model, my y variable, on my x variable, and it will fit a linear model. AB line will automatically draw the line for the linear model. So this is the least squares line that we learned from our regression course. So that works for any y versus x. So notice here when I run this line of code, title, it added this to the title. Okay. I can run this line of code, it added a subtitle. Okay. And now let's detach class data and move on. So once you've built your graph, you can save it using the file menu. Or you can, if you plan on saving it, build the graph one line of code at a time using PDF, PNG, JPEG functions for whatever file type that you want to save your graph as. So make sure that your plotting window is closed first if you're using code to save your graph. You won't be able to open the plot and view it as you make it. So for this reason, I rarely actually make graphs with code. I like to see them being made, and then when I'm done, I just save the plot with the file menu. Okay, so some pseudocode. First, make sure your graph is off. So you want to start with a fresh graph. Then if you want to use, for example, if you want to create a PDF plot, then you'll just run this code, name of your plot.pdf and the PDF function, and it will create that plot and save it in your current working directory. Then you'll make your plot. Then you'll turn your device off. So the first example would be there's no code. I'm just going to click on my plot and then save as file, save as PDF, text sent versus introversion, and you can replace it. I already had that graph already exists, but I can save over the top of it. So that's the easiest way to do things. Now, what if I wanted to use the PDF function? First, make sure your device is off. And now I'm going to run PDF social media data.pdf, and I'm going to run plot class data. I'm going to throw this title on here, and then I'm going to turn my device off. And if you go to your working directory, you'll see the plots. So here's my working directory, day 5, social media. So here's the preview of it. And here's what it looks like. So of course this isn't a really good plot. Needs some formatting, but I just wanted to illustrate the idea of making a plot with the PDF function. Okay. Of course, I ran the device off twice, so there's nothing to turn off. Okay, so now let's show you. Let me show you how to make several plots. So PDF, I'm going to create a PDF called several plots. I'm going to attach the class data again. I'm going to create a scatter plot of text sent by text received, and I'm just going to make things a little less boring and add a color according to gender. Then I'm going to add a title, texting and gender, and then I'm going to make a box plot of text sent. This tilde here will say make a box plot of text sent according to gender. So make a box plot of text sent for males and of text sent for females. So we'll make a box plot of the data for each level of the factor. I'm going to add a title. Now here I want to show you, if I try to open this plot right now, called several plots, it won't let me preview it because it's still making it. If I double click on it, I get an error. So the plot doesn't exist yet. It says it's in use. So that's because I haven't ran device off. Now, several plots, it gives me a preview. Now I can open it, and here are my plots. Okay. Notice the color is red for one gender and black for the other gender. So I'm just easing us into some parameters. All right. What if I want to make multiple simultaneous graphs? So if for whatever reason I want to go back and forth between graphs, maybe as I'm collecting data. So you can create and save multiple graphs using device.new. So device.new will pull up, will tell R to create a new device, or in other words, open a new plot. You can determine which code gets sent to which graph using device.set, and then you type in dev.previous to go back to the previous graph, or dev.set to go to the next graph. So to know which plot you're on, you'll notice that the plotting window will state active or inactive up in the corner. So for example, If I run device.new, a graph pops up. Then I'll run my code to make graph. If I run device.new, another graph pops up, and I'll run my code for the second graph. And I'll show you how to go back and forth with an example here. So here, I'm going to open a new plotting window. Notice it opened it over here. Just going to make a simple plot. Text sent by text receive. Now device.new. Now you'll notice, let me scrunch these down so we can see both of them. You'll notice I now have two plotting windows open. This one says active. So whatever code I run is going to get sent to the active plot. So up here it says active. Now if I wanted to go add a title to this plot, I'll run dev.set of dev.previous, and it'll say, okay, now this is the active plot, and whatever code I run is going to get sent to this plot. So texting, I added a title for texting. Now let's go back to this plot. Now this plot is active by running device.next. And maybe I want to run a subplot or add a subtitle to this plot, figure 2, device off, device off. Okay. And you would have wanted to save those graphs before you turn them off, before you run dev.off if you wanted to save them. I'm not interested in saving them. Specifying graphical parameters. So here's what you're going to need to do to make your plot pretty. I can't go through all of the possible parameters. There's hundreds and hundreds and a lot of different stuff, and we'll get into more depth of how to make pretty plots in a little bit next lecture. But for now, I just want you to get familiar with how to specify graphical parameters. So they can be set using the par function for the R session. So if you use the par function, that will set the parameters for all of the code that gets, for all of the remaining code that's ran until you tell it otherwise. So that, i.e., this will affect all future plots made in the session. You can also set most of the graphical parameters within the actual plot function or histogram function or box plot, so that this will ensure only the current plot is affected by the graphical parameters. So again, there are many parameters. You're going to want to read the help file and just practice. So you just have to play around with this to really get good at making nice plots. All right, so the pseudocode, I can run par as many times as I want. So I can set parameter 1 equals value 1, parameter 2 equals value 2, or I can separate these arguments by a comma and put these in one par call. So I could run par parameter 1 equals value 1, comma, parameter 2 equals value 2. It's up to you. And then I'll run my plot. And the plot will be constructed using the current parameter values. I can also do this, plot my data, parameter 1 equals value 1, parameter 2 equals value 2, and so on. This route will not set the graphical parameters in the current R session, only for this particular plot. So typically when I construct a plot, that's how I do it. Okay, let's run an example. The first thing that you're going to want to do is create something called opar. So this is a nice trick that says par no.read-only equals true, so it's only going to read the current parameter values. So it's going to run par function, and it's just going to read the current parameter values and save them as an object called opar. So if you run opar, it has a lot of information. So let's scroll around. Here's all of the different graphical parameters. You'll have to read the help file to figure out what they do. So for example, opar LTY. LTY stands for line type. How would you figure that out? Read the help file. Help of par. If you scroll down, graphical parameters, starts with ADJ The value of ADJ determines the way in which text strings are justified. So left, justified, centered, and so on. ANN, you can read that, etc. Let's go down to LTY. And you'll see that it says line type. LTY, the line type. Line types can be specified as an integer, so you can specify number 0, 1, 2 for dash line, 3 for dotted lines, 4 for dot and dash, 5 for long dashes, and so on. Or as one of the character strings, you can actually say LTY equals solid, dashed, dotted, etc. Okay, so I can set par. I'm going to set the line type to 2, which recall was dashed line. I'm going to set my PCH to 17. What's PCH? Read the help file. You'll find that that stands for plotting character. PCH. Single character could be used to the default in plotting points. So see points for more information. Only integers and single character strings can be set as graphical parameters. So you can read more. There's a lot to do here for PCH. You can read the points. Click on points to read more about that. CEX, I'm going to set that to 1.5 default. If I remember right, it's 1. CEX stands for, see, there's a lot of CEXs, a numerical value giving the amount by which plotting texts and symbols should be magnified. So I want bigger plotting symbols, bigger text on my titles and axes and stuff like that. So here I increased it by 50% by setting it to 1.5. Okay, so let's run the plot, par, and recall the line type, it's dashed, plotting character is 17, the CEX is 1.5, and let's create a plot. So I'm just going to create a dose response fictitious data. So here's supposedly some doses for a drug, and suppose I have drug A and drug B. Data that look like this. I'm going to plot dose, drug A, type. So I'm going to plot one of the parameters. I'm going to pass that directly through plot. Remember, it can be passed directly through plot or specified using par. So what do you notice? My line type is dashed. My plotting character, 17, if you read the help file, it'll tell you that that means solid triangles. CEX 1.5, you'll notice dose and drug A, and the numbers on the axis are a little bit bigger than our previous plots. They're 50% bigger. What did this B do? If you read the help file, you'll realize that stands for type equals B stands for both. It means both points and lines are included on the plot. Okay, so for example, if you take B off of there, it'll just do the points by default. That equals L. It'll just do the lines and so on. For more information, what you're going to want to do is see help of plot. You can read more. A lot of the parameters, recall, can be specified directly in plot. So one of them that I specified was type equals B for both. And sub, next label, and so on. So now I'm going to reset my original default parameters and pass new values through plot directly. Okay, so par, opar, what did that do? It changed my parameters to my original parameters. So now let's run, for example, line type. Now it's solid, not dashed. So all of my original plotting, all my parameters are default. So par, opar. Now I'm going to create a plot and specify my line type to be 2 and my plotting character to be 17. And what's different? The only thing that's different is that I didn't pass the CEX argument through plot. So remember, I did type equals B for both points and lines. Line type was dashed for 2. Plotting character 17 says plot triangles. The only difference between this plot and the last plot is that CEX now is 1 because I set it to be 1 by using my default parameters. Okay, so as you go to make plots, you'll just want to try different values and see what happens. Read the help file, see PCH is squares for 15, line type 3. You'll see it's a different type of line. Line width is another one I like to use because I always feel like the line width isn't wide enough. So you might want bolder lines and so on. So you'll just have to play around with those. Shut that device off. So here's just a summary for you to read because there's so much here. Most graphical parameters can be specified with a number. So keep in mind, all we really want to do is create a plot and change some parameter values that will tell R how to make the plot. So it will tell it what the plot should look like. So plots and then graphical parameters are the main thing. So see help files for more information. Here's a list of the main parameters. So symbols and lines, you're going to want to look into PCH, CEX for symbol size, LTY for line type. Different colors. So you'll have default color is black. You'll have colors for the axis, colors for the labels, color for the main heading, subtitles, and so on. Text scales, so CEX, CEX axis, CEX label, CEX main, CEX sub. That's going to basically tell you how big all of those things are going to be. So the default is always 1. 2 will make each of those things bigger. So axis portions, text in the axis bigger, text in the label is bigger, and so on. And there's lots of fonts. So read the help files for fonts. You can change the font, the overall font, the font on an axis, the font on a label, the main font, subtitle font, and so on. And PS stands for point size. I can change the point size to be 8 or 12 or 16 or 18. Margins is another one you're going to want to learn more about. PIN means width, height, and so you can change the margin, the width and the height in inches. So P for IN for inches. MAI is margins in inches. You can read the help file for those. So just to give you an example, let's set our original parameters. Let's look at the default plot. And now let's create a new plot and see what changes. And I change some parameters. Okay. So I'm going to change the axis size. I'm going to increase it by 50%. And the font, I'm going to change it to 2. And BG stands for background. I'm going to change the background to green. And I'm going to change my font label to 2. And the color of my main heading to blue. And let's see what that does. It creates this plot. So you'll notice dose, drug B. You'll notice these axes are bigger. So 20, 30, 40, 50, 60 are bigger. My background is green. I also did plotting character 1 through 5. So here's 1 for circle, 2 for triangle, plus 3 for plus, 4 for X, and so on. Adjust for ADG, that means justified. So what this is going to do is 0, if you read the help file, stands for left justified for the main plot. And I'm going to type the word blue left and change the color to blue. Now I'm going to do right justified, if you read the help file. And I'm going to create a subtitle called red right, and color is 2. I put red right down there. So just some different tricks. And I'm going to change my original parameters back. Change my default parameters back. Okay.